I will hopefully have these things back from the copy center tomorrow. But for chapter 10, if you are progressing, what you're going to need to do, we're going to go over a few corrections right now together. You're going to need to correct the problems that you got wrong. And then I'm going to have the other form of the test, because we're going to go over some things right now. So that doesn't really show me if you've actually mastered it. On the other form, on Form K, once I have them back from the copy center, you will find a similar problem. Like if you got one of these wrongs, find a simplify each expression problem and do that on the other form. So when I have those back tomorrow, I'll clarify that. But today we're going to go over a few of these together. 17 through 20 were probably the section where people had the most issues. So I figured we would start here. Now, if you work slowly and you write this all out, it's a lot easier than what some of you guys were trying to do, where you just like try to combine everything at one time and apply everything at one time. And like, you're not being patient enough to give this the time that it needs to get the accurate solution. So, the first thing we would need to do in 17 is what? It's the first thing we would need to do in 17. Calvin?
Distribute the 2/3.
Yeah, distribute the powers, right? So C is going to get a 2/3. D is going to get a 2/3. Then this third power gets distributed, or this cube. So A now becomes 3/4, and D gets a power of 3. Then, though, there's more to do. And some of you guys that got this stuff wrong, I circled like where you had multiple D values still. When we're simplifying, we combine everything possible. So my C and my A values, obviously there's nothing to do with those, but these D values can be combined. But how? How do we combine exponents when we're multiplying the bases? Yeah.
You add them.
We add them. Some people, I believe, multiplied them. So when I combine my D's, I really get D with a power of, well, what?
11/3.
Yeah, 3 and 2/3, but that's not a power. So we would instead say 11/3, which we'll clean that up in a second. C still has its 2/3, and A still has its 2/3. So now, if you want to clean it up, put it in radical form. The denominator tells you your root. The numerator tells you your power. So this, if I put it in the right order, huh?
You said A 3/4.
What?
You said A.
Sorry, yeah. A is not 2/3, it's 3/4. So now if I do my A first, A has a power of 3, but a root of 4. C has a power of 2, but a root of 3. And D is the cubic root of D to the 11th. Any questions there? Because a lot of us missed some of
I
these.
just have a quick question.
Yeah.
So you, alright. I think I know where I went wrong. So you wouldn't multiply the D's, correct? So
No, so
that's where I went wrong.
because when the bases start the same, they stay the same. All you act on is the powers.
Okay. So okay. I think yeah.
So think about it. Like if this was like 5 squared times 5 to the 3rd. Well, how many 5s do I actually have?
5.
2 and 3 more. I have 5 5s. This is really 5 to the 5th. Nothing happens to my base. All I do is combine the exponent values.
I don't know how the heck I got what I got.
Yeah, that's why I thought we should go over a few of these. Because on your guys' solutions, I was wondering
Right, I just
how
somehow
the heck.
got, like D to the 8. I don't. That's not even possible for multiplication.
Yeah, so that's what I'm trying to make you guys analyze.
How many people mastered this?
I don't know. I mean, some people did, some people didn't. This one was a little bit rougher than the other assessments that we've had this year. So, a lot of people missed 18, 19, 20. Like 17 wasn't so bad. What's the first thing I need to do here? Same thing as last time, Brian.
Put the exponent into the thing above.
Distribute the power
Yeah.
into the expression.
Yeah.
Although I do like thingamabob as a word. So, it is a fun word to say. we are going to square both of these. They're separate. Even though they're one term, the values are separate. So if I had 0.25, it's really a fourth. What's a fourth squared? What's a fourth times a fourth? No, a 16th.
You played yourself.
So this
Halfway there.
becomes a 16th x. Well, what would the power of x become?
A 16.
No. Think. We're going to square
Oh,
a fourth power.
a half.
Yeah, because it's 2/4, which really is a half.
You're right.
Man, I know.
And that 12x to the third is just 12x to the third. Here's the thing. This is a string of multiplication. I can use the commutative property, and a lot of people got our coefficient wrong. If we combine the 12 and the 1/16, I get 12/16, which reduces to 3/4. When I combine my x to the half and my x to the third, we add the exponents, and I would get x to the 3.5, which is not proper. So we would instead say x to the 7/2, which really square root of x to the 7th.
What's the stupid coefficient?
Oh my god.
Wouldn't 3.5 be the proper one, and 7.5 is the improper?
Well, okay. So this is not a proper power, is what I meant. That's a proper mixed number, but it's not. We don't write powers like that. Yeah, that's what I meant. Is we can't leave it like that. That's like unacceptable. Yeah.
Question. This is a cool question. If you would have kept it in that 3.5, like
You
state-
can't.
Okay, I'm saying if you would. I mean, I didn't. I simplified
Yeah.
it. If I would have, would you have counted it wrong?
Yeah, because you can't leave it like that. That's not an acceptable power.
Okay.
Because it's not the third power, it's not the fourth power, and it's not even communicating that it's a power between 3 and 4. It is the square root of the 7th power. So you got to communicate what it's actually saying. Yeah.
Even if it was acceptable, it'd still be wrong because it says to put it in radical.
Exactly, yeah.
Oh.
And some of you guys, I highlighted that. Like on the first section, I highlighted some of that stuff. I figured we'd go over all 4 of these and then any requests that you guys have. When you do 19, guys, and if you have this wrong, I expect that you're like writing down and focused with me. What is a power of 2/3 really communicating? Because the what?
Where does the cube root?
Yeah, the cube root of a square, right? So really, this I can rewrite as the cube root of 27 squared times x to the 2/3. Then times, well, a 5th power is really the 5th root of 1024. And I had some people who tried to combine the coefficients before they applied the powers. You gotta follow order of operations. Exponents happens before any of the other multiplications allowed to happen. And then I still have 5th root of x, or x to the 5th, since I'm going to combine these. 27 squared then to the cube root, combined with the 5th root of 1024, gets me, crap, what was that?
36?
36.
Yeah, 36. Thank you. I was trying to remember from when I was reading those. So if you square 27 and then take the cube root and then take the 5th root of 1024, those values, the product of them, is 36.
Wait, even?
Yeah, like
Yeah.
36.
36.
So 27 squared.
I got 36.000.
I know, I saw that. 27 squared is 729, right? 729. The cube root of that, or I can take it to the power of 1/3 if I want to cube root it a different way, is 9. So this value becomes
you just
9,
simplify that to 9x.
and this value, isn't this is 4. Yeah. Because you know it's a power of 2. 1024, like we know it's a power of 2
I know I
if
did
you're not
wrong.
familiar with that.
I instead of doing what you did, which was the root thing, I just did the multiplication, and I got 9 since that goes evenly. But if you do the actual math, like automatically, so for some reason it comes out with 4.0008.
I bet you if we like dug deep into that, we could figure out why it did that.
I don't know why. I just know when I did the math on my calculator, it came out with 4.008.
You don't have your calculator do too much at once. That's the problem, is it gets confused, especially when we're dealing with roots and powers and multiple different things. So then, x to the 2/3 times x to the 5th, we need to add these powers. Guys, almost everybody got, well, I don't know about almost everybody, but a lot of people got the power of this x wrong. We have to add these, not multiply. A lot of people multiplied this. So when I add 2/3 and 1/5, I need a common denominator. Ethan, what's my common denominator? 15. So this 2/3 is going to become 10/15. This 1/5 is going to become 3/15. And when I add them, I get x to the 13/15, which then
I put the 15th root of x to the 13th and you marked it wrong.
I did that too. I did that too.
maybe there was an error on the key. Hold on a minute. I don't always check the key for errors because I would have thought that we would have found it before.
How did I do this wrong? I thought this was alright.
Yeah, 36 times the 15th root is x to the 13th. Ha, I said it right.
Maybe if that was the answer, I'd be 0.0072 off.
When you get a chance to have this open,
Thank you.
Mm-hmm. All right, I see what happened. There was an error in the key because they looked at these separately, and I was just working fast. And I'll admit it, guys, when I make mistakes, I work too fast sometimes, just like you guys. If you work too fast, you miss things. So the key had those two separated. You can go ahead and put a check on it yourself, like on your test, and you don't have to do a correction for that. It's going to be the 15th root of x to the 13th. If you didn't combine these, since they didn't have common denominators, the key had 36 cube root of x squared times 5th root of x.
That's not simplified.
Hmm?
That's simplified.
I know. And 20, let's check that there wasn't any error there. What is a negative power actually telling you to do? Straveler?
I think it's like put 1 above the answer.
Yeah, apply that power in the denominator or in the reciprocal. So I can do that right now before I even distribute that. I can just make this 1 over a to the negative 1/4 b, or sorry, now that would be positive 4 b squared c. That's negative 1/4, right? Check on your paper. I can't tell on the
Yeah,
screen.
it is.
Yeah, so this becomes 1 over b squared c to the 1/4. From here, we distribute the power, just so I make sure I'm not wasting time. People want me to keep going, yes?
Yeah.
Okay. So then I distribute my powers. So don't do too much at once. Powers to a power multiply. Negative 1/4 times 4 is negative 1. B to the 4th, I just get b to the 4th. B squared to the 1/4, I get b to the half. And c just becomes to the 4th. Now put things where they actually go. A to the negative first power really just means, oh wait, flip a back to the top. So my numerator becomes a, and it's the only thing up there. B to the 4th combined with b to the half, I need to add those with each other. I get b to the 4.5, which we don't write it like that. We would say b to the, well, close. This is not multiplying. We have to add these. Remember, it's not power to a power, it's power times a power. So this is 4.5, or really 9/2, but we wouldn't write it like that because we want to simplify it in a radical form. So it'd be square root b to the 9th. and then 4th root of c.
Oh, I put it in the wrong place. Okay. Can you get that up just for a second?
Yeah, I'm going to capture it up to the TV too. Are there other questions from actually, because I want to give you guys time to look at this on your own. We'll start class tomorrow again with questions from this test, because then I'll have the other form, like you're progressing to mastery. So we'll start class again with this. So as part of your homework tonight, just glance through the test, see if there's things you can't figure out. We'll go over those tomorrow again. Yeah.
So just a question about the test that
Yeah.
we'll be doing. Do we have to be like the exact same number, or would it be a one in the section?
No, it'd just be like in that section. Yeah, the numbers will be different. So you're just trying to find a similar problem, and the choice will be up to you. Like if there's 4 problems in that section and you only need 1, you pick one of the 4.
Okay.
So how many questions do we have to do? Like,
So say you got 20 wrong.
Alright.
It's in the section of simplify each expression, write in the radical form. You'd go on the other form test, find a question in that section, and just do that question, whichever one you want. I'm leaving it up to you guys. I make your guys' stuff pretty open requirements because first off, I trust you guys, and second off, you're responsible. So it's easy to make it open. Yeah.
Just to be clear, so we're doing the corrections for this test and we're also doing the retest. If we
Yeah,
don't
but
know.
I will help you with any corrections you need. So like you're not on your own with that. I just want you guys to look at it on your own this evening, and then we can go over it again tomorrow. I just want to take some time to get through the sphere lesson because we only have 25 minutes left.
Okay.
Let's talk about spheres.
Ooh. Halloween.
You know your shape.
You're confused? No, if you got mastery, you're fine. You're good. You're mastered. You're good.
Yeah, I was so confused.
Nope, you're fine. Do we have these notes? I believe we should. If Brian has his notes, we should all have our notes. I know. I'm saying if you have them, everybody should have them.
Yeah, if Brian
Sure.
has them, you should be putting them in.
Little to the side.
Yeah.
If he
Aiming
hadn't
for my
caught
smartboard?
that, it would have went right through the smartboard.
Mm-hmm. I have a glitch spot right about here, and I think it's because I like normally am like pointing right there or whatever. Like, so I'm trying to be gentle with my smartboard now. It's starting to get screwed up. What I love about spheres, and this actually was on Who Wants to Be a Millionaire. I forget when it was, and I wish I could find this episode. But on Who Wants to Be a Millionaire, there was a question in like the hundreds of thousands of dollars of how. It was actually a really interesting question. It said if Pac-Man is assumed to be a perfect sphere and is 3 feet wide, how would we calculate the volume of Pac-Man? So all they needed to know was the volume formula for a sphere. They lost. And I was screaming at the TV because I love how these formulas work together because it's because they're easy to remember once you see the trick. For surface area.
It all comes back to trig.
Wait, you know what
No,
the funny
trick,
I know,
not
I know,
trig.
I know, I'm kidding.
So check this out. Surface area uses 4 pi r squared. Both even values. 4 pi r squared. Volume
It's the very bottom.
still uses the 4. Because it's a circle, we still use the 4. But then it's 4/3 pi r cubed. So we know that volume has to be a cubic measurement. So that tells me first square versus cube. And then I know that if I'm using my cubic, I have to divide by 3. If I'm using my squared, I don't do anything. I just have the 4 pi r squared. Volume has that 4/3 pi r cubed. So in my head, that's what always worked, is 4 and 2, they're both even. 4/3, we have that 3 on bottom, and then the 3 in the power. Yeah.
It's really interesting that the surface area is just 4 of the center circle.
Yeah. And there's really interesting proofs that kind of look at, like, how could you take a sphere, like a perfect sphere, like a basketball or something like that, and cut it into pieces and try to make the 4 different circles. But like it is really interesting that the amount of space around the circle is just 4 times the center disk.
I saw
Yeah.
this thing that made it look like pi was actually equal to 4.
That pi was equal to 4? What do you mean? Like a proof method that was...
It was a proof.
Yeah.
It makes it look like it if you don't know your stuff.
Yeah, there's a proof where 1 equals 2. because there's like this assumed rounding and different things that it kind of falls apart. But if you don't know your stuff, yeah, you can make one
It
equal
has
2.
like a square and a circle, and then if you fold the corners in infinitely, then the square will become a circle. But the perimeter will be the same.
But it's not technically a
It will
circle.
always have tiny ridges.
Right.
which-
It can be like a 1 million gone, and it's still not a circle. It is a circle by what we can see. But like even circles on our screens, they're not real circles. These are pixels, so they're all actually squares. So like we represent that it's a circle, but technically, like we can't make a perfect circle on a screen because they're pixels. They're all squares. So that's the problem.
The same for in real life. This is all atoms.
Yeah, that starts to argue semantics, though, which I love arguing semantics. We just don't have enough time here. I also have a mathematical proof, if you're interesting, and I could work it either way, that either men or women, whichever way you want to work it, are the root of all evil. Like literally the square root of evil. Yeah.
Proof that all girls are evil.
Yeah, so the one that I know is women are the root of all evil, like the square root. Because it's like women take time and money, time equals money, yeah, that whole thing.
And then
Okay.
money is the root of evil.
Yeah, exactly.
So women equal evil.
So, surface area. Write the original formula, please. I'm hoping that you guys are starting to trust me, that when I tell you something, it's not just because I want to make you do work. When you write these formulas, it starts to cement it into your memory. So when we write that surface area is 4 pi r squared, every time you write that, that's going to help you remember it in the future. So then, what is my radius here? 5. Sorry, Brian, Caleb, thank you for raising your hand. 5 squared. Just go ahead. Times 4.
100.
We get 100 pi meters squared. Careful, I heard a cube there.
I know.
So, approximately in decimal form, this would be about 314 meters squared. If we wanted decimal form.
Wait, meters. Oh, yeah.
You know what would be interesting, Calvin? And I wonder if I can find something about this. To compare the surface area of a sphere, like basketball, whatever, to like a football, to like a rugby ball, to like the different types of oblong spheres, like not spheres, like oblong spheroids. Like, so the Earth technically is not a sphere, it's an oblong spheroid.
An oblong.
Because it is stretched one direction.
Is it
You can shake your head no, that doesn't make it not true. The Earth is not a sphere. Alright, back up here. We're trying to move quick.
My kindergarten teacher lied.
Try this on your own.
Thing.
Try this on your own. When you're telling kids, you just tell them it's a perfect sphere. But it's not technically.
I mean, they
Which
don't
actually
know.
means you weigh different amounts in different parts of the world because you're a different distance from the center of the Earth.
If you want to lose weight, just move.
Yes, but it will be a minute difference. So, yeah. Try this on your own. Don't look back up here until you think you have an answer.
Oh, I got it.
Hey, guys. Please solve this out on your own.
See.
Then you already solved it on your own. Chill. JD.
Got it.
Check up here and make sure that your answer agrees with mine and that I did not make a mistake.
You need without pi also, like the both answers.
Hmm?
You need the answer without pi also.
Oh, yeah, and the nearest square inch. So, I'm betting this is really close to 600.
It's
615.
615?
But it's rounded to 616.
Yeah.
Meters or inches squared. Inches squared.
Meters squared.
So, this, and this is why I said this already. This problem is using the word approximate because the Earth is not a sphere. So we can accept that it's close enough to a sphere that we can use our sphere formulas. But just be aware, it's approximate because it's not technically a sphere.
Do they know the exact?
I mean, like, we know the dimensions. It is an oblong spheroid because it's not a perfect sphere, but it's close. I don't know. Look it up. Find out if they do. Like, I would be curious. You can look it up now if you
I
want.
don't have my phone.
Why?
Boys.
But if we assume the Earth is, then what does knowing the equator's distance tell us?
It's the diameter.
Caleb?
It- I was gonna say, you know, the equator's distance, so that's the thingy around it, you know, circumference.
So this is actually the circumference of what we're accepting as a sphere. So to derive the radius,
Divided by pi.
we know that this is 2 times pi times the radius. So we divide by 2 pi. Because remember, circumference is really pi times diameter. So, Caleb, if you just divided by pi, you'd get your diameter. If you divide by 2 pi, you get your radius.
Well, I mean, then I can just divide by 2.
You're right.
Still get it.
But as I say, mathematicians try to be efficient. I don't want to do 2 steps when I could do 1 step.
But you'll take the time that would take to do 2 steps.
No,
Thinking of
because if I only have to punch the calculation in once, I only
That's
add one
brain
more
energy
button that I hit.
wasted.
those are my brain cells being.
So, what's the radius? What do you get?
I don't know.
3963.
0.276.
Oh, dang it.
Yeah,
For some reason, I got a bigger number than I originated with.
No, it's not.
I know, I was like,
Yeah, you couldn't. That won't happen.
No, I mean, seriously, I typed in. Oh, it's because okay, never mind, I get it. Because I had put pi at the end, but I forgot on this calculator, it does that afterwards. So it's like, how did I end up with.
did that too.
So I'm not going to write this out because here's why. You should not let your calculator clear. When we're dealing with large values, especially when your calculator runs out of space on the screen, do not write it. Well, you can write it down if you want, but do not let your calculator clear. It actually has more value than you realize. So leave it in there, square it immediately, then multiply by your 4 and multiply by your pi. And of course, you can multiply by 4 pi at the same time if you choose. But our surface area comes out to be approximately
197 million. Well, there's more. 197,387,017.
Oh, I got it now.
Is that the end of it? Is that where the decimal is?
1.5.
To the nearest square thousand.
So to the nearest 1,000 square miles, then, we would have 197,400,000 approximately.
What?
No.
What
No, I didn't get that.
I didn't get that.
That's right.
I got that.
Let me check the math.
Check
what you calculated.
Nearest 100,000.
Oh, no, yeah, okay, I got it. We good.
It's nearest 100,000.
Yeah,
Not nearest 1,000.
Yeah, it says nearest 100.
no.
No, it doesn't.
Oh, sorry. So 387. I thought you meant like we were way off.
That's a little bit above the actual.
Yeah, what is the actual surface area?
196.9 million miles cubed.
So where this comes from is the circumference around the equator then must be bigger than if we flip it and go on the Tropic of Cancer. That must be a smaller, so our oblong spheroid. But think about this. How does the Earth spin about its axis? Like this, right? We're spinning like, around, not top around.
Axis is like at the end.
Right. So think about, and I wish I had a ball to show this, but think about something spinning. What happens? Actually, this is a great example. What will happen when I spin my perplexix? Because you know what's inside of here.
Ball move.
Where's the ball go?
The other side.
Why does the ball go to the outside?
Because centrifugal force.
Centripetal, or is it is
It's
centrifugal?
Centrifugal.
Centrifugals out?
Yeah.
So, what has happened is in the billions of years that the Earth has
Billions,
existed,
guys.
Stretched.
we've stretched.
We've
The
stretched.
spinning force of the Earth has essentially taken the matter, because matter can't be created or destroyed, it's all still here, and it's literally just let it stretch outward. The longer we exist, spinning like we are, we could assume or hypothesize that we'll keep stretching slightly more wide and compressing slightly down.
Yeah, what do you get?
Yeah, so in, trillions of years,
The sun will have.
yeah, the sun will have exploded before our Earth would ever get to a flat point.
But
Well, then we
it
should
could.
contain the
So does that mean the
explosion.
Earth is actually flat?
No. No, it does not.
We should.
You cannot make that a valid argument.
So.
Are we good on surface area? Can we go to the back?
Yeah.
Let's try some volume.
Contain something Brian can't do.
Oh, so true though.
Write your original formula. Write your original formula. 4/3 pi r cubed. Recognize the 3 in the denominator, the 3 in the power. Our radius here is 6. 6 cubed is going to give me 36 times 6. 216. I'm going to use my commutative property, move things around slightly.
216 times 4/3 is 288, I believe.
I think this question is on the homework.
Probably, some of them repeat.
Yeah. Let it happen, Michelle.
Or meter sphere.
Meter sphere.
That should be a measurement. Meters, sphere.
And I'll create a new number so that we can make it meters.
Meters.
Hey, I got a plan. I almost forgot to ask you guys this question. Would you rather, we're like about ready to take your chapter 9 test, like either end of this week, beginning of next week. Would you rather take the chapter 9 test Friday, which of course Friday test, no homework, yada yada. Then Monday I have to be gone for a meeting over at the WEC. I'm gone all day. So here's the options. When the sub is here, you would, if you took the test on Friday, I'd have a chalk talk lesson for 11.1, and you just watch the lesson, fill in the notes, and you'd have homework. Or the alternative choice is to flip it. Friday we would do 11.1 to start that section and just get our feet wet a little bit. Monday, you would then just take the Chapter 9 Mastery. If you don't finish or if you have any questions or whatever, Tuesday, when I'm back, we can then wrap that up.
Okay.
Wait, what are we doing tomorrow?
We're reviewing Chapter 9, like problem-solving
Yeah,
practice
then
sort of
yes,
stuff.
then
Yeah, I
yes,
might do
yes.
like...
Then Friday.
Then yes, what?
Friday.
Okay, so, question.
I
Friday.
personally think it would be better to do it on Monday so that the sub isn't teaching us or there when we're doing
So the sub's not going to teach regardless, but I agree. I know. They're not as good as the live show.
The
No.
live
This is what Mr. Hall and I have kind of decided. Like, yeah, the recorded version's good. Like, when you watch, like, the Blue Man Group recorded, like, that's cool. But it's not as good as the live version.
Chicago is way.
Isn't
Chicago
11 a tough
overrated.
one anyway?
Huh?
Isn't 11
Like,
sort of tough anyway?
It gets into combining polynomials and that sort of stuff. So let me, for what it's worth, in my opinion, I think it'd be a better idea for us to do 11-1 face-to-face on Friday and do the test on Monday. That would be my preference, but I want your guys' opinion. So shut your eyes. If you want to take the test Friday as soon as possible, and then you'd have a chalk talk for 11-1. Take the test Friday. Okay, put them down. And as always, there's an I don't care option. Take the test Monday so that we do 11-1 face-to-face. All right, put them down. If you just don't care and you're along for the ride. Okay, all right, put them down. We're almost exactly split, so I'm going to have to think on this. But I'll get back to you guys tomorrow
No,
on
you're
that.
like a tiebreaker. You prefer Monday, so let's do it Monday.
Let's do Monday.
One of the days you'll have no homework regardless. Like, it doesn't, it's not like I check your homework the next
Let's
day.
make it Monday so we don't get off to a rock start.
But you could just do Friday's homework on Monday. Because it's not like I'm going to be here. So that, if you're arguing based on homework, that's the wrong thing to, like, convince yourself with. Sphere is a diameter of 60 inches. Let's calculate the volume. If you haven't done so on your own yet, go ahead and do this.
Wait.
you don't even need a calculator for this to get it all the way to terms of pi. You really only need a calculator to get to your nearest cubic inch.
Dang it.
Because, do you know what 3 cubed turns into? 27, right? So what does 30 cubed turn into?
27K.
27,000.
Ooh, I've heard 3 different answers now.
27.
So if I had
27,000.
30 times 30 times 30.
It's 27,000.
Gangsterism.
Your 3 times 3 times 3 is 27. But then we have 3 zeros. So we get 4/3 of 27,000 times pi. Now 27,000 divided by 3, 27 divided by 3 I know is 9. So this would be 9,000. 9 times 4.
36,000.
So I get 36,000 pi without ever needing a calculator. Then give it to me.
113,097 inches cubed. I got it.
Dang, that was.
We have video proof that I have it. I got it.
It could have been someone else.
It's so weird because they said it in the same
Yeah.
speed.
Oh, man.
I know when it's creepy when they say it at the same speed.
Well, it wasn't as creepy as when Carmen and Brian
Oh,
were
that
saying
was
at the exact
terrifying.
same time.
So now we get into the tough part. If you've been given the surface area or been given the volume, I can use either of those to derive the other. So what we're given right here is the volume of a sphere, and we need to determine its surface area. How do we do this? Well, let's go Caleb, since really I called on Caleb and you spoke over top of him.
So you could work backwards. Since you know the volume and you know how you get the volume,
Okay.
you could just work backwards.
So what do
from
I
there.
set up?
So you could go 5,000 meters cubed. That doesn't mean you don't really need it. At the current moment. Equals I got 4/3 times pi times radius cubed.
What's the easiest way to get rid of the 4/3?
3/4 times 3/4.
Yeah, multiply it by its reciprocal. So if we multiply by 3/4 times 3 would be 15,000 divided by 4 gives me
3,750.
then of course to get the r cubed by itself we want to
Divide by 3/4.
yeah we got to divide by pi first, don't forget that. Gonna get a little over 1,000.
1,193.6.
Said 1,193.6.
0.7.
0.7.
Yeah.
And the cube root of that, or you can multiply, or you can raise it to the power of 1/3 if that's easier in your calculator, which I think it is. Because then you can leave your answer sitting there and just hit the power button, parentheses 1/3.
10.6.
Thank you. I was about to say, it's going to be close to 10. But that is now our radius. Not done yet. To take that and find our surface area,
Clutchow.
what's our formula again?
4 pi r squared.
4 pi r squared.
So good. I'm on fire. My aura is surging.
So now, I got to do my 10.6 squared,
112.5.
and then multiply that by 4 pi, and we'll get a final surface area.
Of 14.
And it was so close to being 14.
Meters squared.
No.
Calvin.
He's stealing your thunder.
Yeah, Calvin, you're stealing my fuego right now.
Well, then maybe it wasn't yours to begin with.
It was. I got there.
Toasted.
Ah, okay. For a second I thought it cleared without
Not
capturing.
as bad as this.
Questions on this process?
Fair enough.
I'm like a piece of toast these days, Brian.
I've kept you a minute or so late a couple days, so I want to get you guys out of here a minute or so early so you can head out to your next place. I assume that you guys would be fine on the got it. I will tomorrow take questions on the Chapter 10 test, first things first. Then we're going to review all the Chapter 9 homework and make sure that we're good on that, take any questions from that. Then if there's still time left over, we'll do a little review game.
Coolio.
Okay?
We play Jenga
Yep, that's the plan.
on Tuesday.
Tuesday? No, man. End of the chapter. End of the chapter stuff.
I know, but like just to keep it in.